All right, I wanted to go ahead and actually record some videos about impulse and momentum just to give us some working equations that we can use in AP Physics. So we've got two big topics to cover. The first topic is the impulse momentum theorem. And what it says is the following. You have this quantity F times delta T, which we'll call the impulse, labeled with the letter J. And what the impulse momentum theorem actually says is that the impulse acting on an object results in a change in the object's momentum, where momentum is this quantity m times v. So that's the first big point. And then the second big point we're going to deal with is a principle called the conservation of momentum, which says that in an isolated system, when you take the momentum of all the objects initially, add it all up, let them run into each other, hit and collide, and then you add up the momentum after they've done all that colliding, the total momentum will be the same. Another way you'll see this written for two objects, which is typically what we deal with in AP Physics, is m1 v1 plus m2 v2 initial equals m1 v1 final plus m2 v2 final. And this principle is called, the conservation of momentum. So the first thing we're going to do is we're going to basically split this into two parts, okay? So we're going to talk about first the impulse momentum theorem. And before we talk about any of the math behind it, I just kind of want to motivate, why are we even studying these laws in the first place? So just to be clear, impulse and momentum are two concepts that are useful in studying collisions. And specifically, we're talking about things like hitting, firing, exploding, and crashing, etc. So we're dealing with really large forces and really small times. And first, the impulse momentum theorem itself is another way of rewriting Newton's second law. It's a way of writing Newton's second law for collisions, crashes, etc. So it's N2 for collisions. And here's how we start. So we know that the sum of the forces acting on an object results in the mass accelerating. Now this vector sum of the forces we can just denote as the net force. And the effect of this net force is just the acceleration, meaning the net force acting on the object makes it accelerate. It makes it speed up, slow down, or change direction. Now here I'm going to make one small substitution. So on the web page it said delta V over delta T is the acceleration. We can write it more like this. We can say that since V is AT plus V naught, So we have v minus v naught over t equals a. And we're going to do a little substitution here. So we have that the net force equals m v minus v naught over t. So we end up getting F net times the time for which the force acts equals mv minus mv naught. So we have some definitions. P we're going to define as being the letters m times v, and we call this the momentum. F times t is called the impulse. And this is one way of writing the formula, that impulse is the change in momentum. And we'll also see this written with the letter J. So you'll see this written as J is delta P, or F times T is delta P, or finally this formula here. So that's the first big idea. One other thing I want to be clear on is it turns out that if you have a plot of F versus T, and this is like a function graph, this area is the impulse. So that's the first big idea of today. And now just another smaller idea that we're going to do. Actually, it's a pretty significant idea because it's a conservation law. So here's the idea. Suppose I have two objects, I'll call them A and B, or 1 and 2. So number 1 and number 2, and they're rushing at each other. So m1 moves at a velocity v1, m2 at a velocity v2, and these are initial velocities. And then they hit. So boom. And then they go in opposite directions. So v1 final, v2 final, m1, and m2. So here's the idea. When they hit, it's kind of like you have 1 here and 2 here, and they're exerting forces on each other. So when they hit, we have a force on 1 due to 2, and that's the opposite of the force on 2 due to 1, and this is from Newton's third law. Now here's the thing, the actual collision time for each is the same. So that means they have the same impulse. Well, if they have the same impulse, they have the same change in momentum. So we can actually write m v1 final minus v1 initial, that's m1, equals negative m2 v2 final minus v2 initial. Let's multiply out. m1 v1 final minus m1 v1 initial equals negative m2 v2 final plus m2 v2 initial. When we gather all the initial terms and the final terms on the same side, so put initial terms on one side and final terms on the other, we'll end up getting m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. And we call this principle the conservation of momentum. These are the two big ideas that we're going to be working on this week. And in the next video, I'm going to do a couple of basic example problems.